This is the Precalculus CPM Chapter 1 exam on tools, version D. Okay? So number 1, we were given this function, h of x is equal to 1 over x minus 4 plus 2 pi. We want to state the parent graph in part A, and B, describe the transformations from the parent graph. Okay? So part A, the parent graph, is just without any shifts or transformations, so we're going to take out the 2 pi, take out the 4, and we're left with just that 1 and the x. Okay? So this is the parent graph, right? You take out that shift, it's the parent graph, and we know it as the reciprocal. Oops. Whoa, reciprocal, right? Function, right? It's just the 1 over x function. Okay, so then what are the transformations that took place? Well, over here, right, in our input, the input is going to be minus 4 to change this x to x minus 4. That minus 4 is going to be a horizontal shift right, okay, by exactly 4 units. All right, and the plus 2 pi on the outside of the function is going to be a vertical shift up exactly 2 pi units. Okay, if you weren't happy saying 2 pi, you could say 2 times 3.14, which is 6.28 units, and then you would say approximately. Okay, but 2 pi units exactly, and that's the answer for part B. Okay, that's all you had to do. You didn't have to graph anything, and you're done. So let's go on to number 2. Number 2, we were given f of x is 3x plus 4, and g of x is the square root of x minus 6. Part A, we were asked to find f of g of x. This is not multiplying. This is f is a function with the input being another function, the composition of functions. So remember what we do here is we just take f, we ignore the outside here, right? We just find what g of x on the inside is defined to be and copy it in. So let's go ahead and do that. That's just x minus 6. Exactly. So g of x right here is x minus 6. Okay? Then we look over here. Well, f of x is basically taking in x, and then it's multiplying that by 3, and then adding 4. So it's just taking in the input, 3 times the input, plus 4. So now we have f of square root of x minus 6. This right here is the input, so that's what we're going to write right here, and we're just going to do 3 times that, and then add 4. So what is that? Well, let's copy it in. It's x minus 6, right? So that's, I'm going to rewrite it. It's just 3 times square root of x minus 6 plus 4. And we're done. That is f of g of x, okay? One word of caution, some people try to just shove this 3 in the square root and distribute it. You cannot put the 3 in the square root. If you wanted to put the 3 in the square root, you would have to first put the 3 under its own little square root. So what is going to be here? Well, square root of 9 is equal to 3. So then if you had this, right, then you can distribute and make this all under one big square root, and it's just 9 times x minus 6 then, which you can then distribute the 9 across, okay, like that. But you cannot distribute that 3 inside unless you make it square root of 9 and put the 9 inside, okay? But right here is the answer for part A. So for part B, we were asked to find the inverse function of x. Hint, unwrap. So remember, find the inverse function. First, we need to find out how the function itself was created. So f of x, starting at y is equal to x, the first thing we did was multiply by 3. Then we take that, we add 4. Okay? So those are the steps to create it, to wrap it up. So to unwrap it, we do the opposite of what we did in the opposite order. We start down here with y is x. Adding 4, well, the opposite of adding 4 is subtract 4. Multiply by 3, well, the opposite of multiply by 3 is take what's here and divide it by 3. Okay, the whole thing. So right there is the inverse function of f, the inverse function of f. X minus 4 over 3. Box our answer, and we're done with number 2. Okay, so let's go on to number 3. Number 3, we were given a graph of f of x. It looked like this. Okay, yours looked a little better. It was on graph paper and all that, on the grid. And then we were asked to then sketch negative f of x minus 1. Okay, so we have to remember then is the input here, x minus 1, means, let me use a different color. That minus 1 means shift to the right. So horizontally shift right by 1 unit. That negative means reflect across the x-axis. Okay, just abbreviating that. And then what do? Well, we shift right first. So let me do it in 2 stages. So shifting right by 1 unit, okay, every point moves to the right 1 unit, okay, right 1 unit, right 1 unit, right, these all are connected, right 1 unit, right 1 unit, right, like this. Okay, so that's shifting to the right by 1 unit. Then we reflect, I'm going to use blue, this in green across the x-axis. So this point reflects down to here, like this x-axis right here is our mirror. These all reflect here. On the mirror stays, oops, we're looking at the green one. On the mirror it stays there. Right here, moves up to here, so it's going to look like this, right? On the mirror again it stays there, and it's going to go down and look like this. Okay? So in blue, we shifted it to the right by 1. From red, we shifted it right, and then we reflected it across the x-axis. Okay? So there is the sketch. Okay? Let's go on to number 4. Number 4, we were given a triangle and asked to solve for the missing side value, right? We're asked to find this missing side. So what I always do when I get a triangle is I label the sides and the angles. So the vertices are A, B, and C, capital letters. The opposite sides are the lowercase. Right? First step. Okay, now we want to find side X, which is C. Well, we know 2 angles and 1 side. So it's not a 90-degree triangle, or if it is, we don't know yet. Right? So what can we do? We can use the law of cosines, the law of sines, or we can use the fact that you add up all 3 angles in any triangle. The degree sum is 180 degrees. Okay? So the law of sines, we would need an angle and the opposite side. We have an angle and the opposite side here, right? We have angle B and little b. But we don't have angle C or little c, and we have angle A, but not little a. So some people went ahead and solved for angle, side little a, right, using the law of sines, and then used the fact that we have A, B, and then you could find angle C by adding all the angles up to equal to 180, and then using the law of cosines to find C or X. Okay? But what I would do first, okay, there's a couple ways to do this, but I would first start off by saying angle A plus angle B plus angle C is 180. Plug in 30, 110, and solve for angle C. Okay, oops, making a few mistakes, and I get 40 degrees. Okay, so now I have an angle, and I'm just looking for the opposite side, and then I can use the law of sine. Sine of angle B over little b is equal to sine of angle C over little c. Plugging in these values, I have sine of 110 is B over 25 is little b, is sine of 40 degrees over little c is x. So I'm going to use this to solve for x. Okay, all I need to do now is solve for x, simplify, multiply x by both sides, it cancels there. Multiply 25 by both sides, it cancels there. Divide both sides by sine of 110, it cancels here, right? So I'm left with x on the left, everything else canceled, sine of 40 degrees times 25 over sine of 110 degrees. Bring out my calculator, plug that in. Sine of 40 degrees times 25 divided by sine of 110 degrees. Okay, so x is approximately 17.10 units. Okay, I'm just copying that, box my answer, and I'm done. Okay, done with number 4. So let's go on to 5. It had a part A and a B. Part A, we were given a circle and the angle. Remember, now we're going in the negative direction. And we want to get the special angle that is drawn in the figure. Okay, it was drawn a little better when you had it computer generated. But what you have to notice is, since it's a special angle, this section here, quadrant 3, is either broken up into 2 pieces or 3. So this one is broken up into 3, right? So if this is broken up into 3 all around, we know one section starting here to here is pi over 6 radians. So going in the negative direction, we start at 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, done, but it's in the negative direction. So it's negative 4 pi over 6. Simplify that, we get negative 2 pi over 3, and this is radians. This is also radians, and we're done. Okay, that was part A. Part B, again, now we're going in the positive direction. This angle we can see splits quadrant 4 into 2 equal parts. What you have to remember is when you split this into 2 equal parts, this one section is pi over 4. Okay, so when we go around the circle, we start here, we go pi over 4, 2 pi over 4, 3 pi over 4, let me finish drawing those, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Let me write that in darker blue. 7 pi over 4, and that's in radians, and I'm done. Okay? Finally, number 6, we were asked to convert between radians and degrees. So what we had to know was 180 degrees is pi radians, or 360 degrees is 2 pi radians. Okay? Then we want to multiply the conversion ratio, either one, choose just one of them, with radians in the denominator and degrees in the numerator. Pi and 180 is what I like to always use. Radians cancel out because this is over 1. Multiply across. 0.5 times 180 is 90. 1 times pi is pi. So it's 90 over pi degrees. That's a great answer. You could plug it in your calculator. You get 28.648 degrees approximately. Either one of these was okay. Okay, you're done. Move on to 6b. 400 degrees. We want to multiply the conversion ratio with degrees in the denominator to cancel this out. Radians in the numerator. So that means pi and 180, right? Multiply across, you get 400 pi over 180 radians. Simplify this, you get 20 pi over 9 radians. You can plug it in your calculator. You get 6.98 radians. Either one of these answers was accepted for full credit. Okay. Number 7. Number 7, we're asked to factor. And this was exactly the problem taken from section 1.4 quiz on the unit circle. So this is the exact problem from section 1.4 quiz, which has a video all on its own. So you can review that video to do number 7 if you got it wrong or you have any questions. Okay, so this ends the Precalculus CPM Chapter 1 Tools Exam review of version D of the exam.